Hey guys, Mr. Sherman. I'm going to be teaching you about the fundamental theorem of calculus, and this fundamental theorem of calculus is actually broken up into two parts. So those will be two sections in class. So it's for things in calculus. It is probably one of the most important things that you learn just in terms of mathematics. It basically tells us how to use integrals and antiderivatives together in a practical way. So what the first part of the fundamental theorem of calculus tells us, it tells us that assuming that f of x is continuous from a to b, and that's little f, if big F of x is the antiderivative, then the integral from a to b of little f is equal to capital F of b minus capital F of a. That seems kind of weird and abstract. I will show you some examples that will kind of illustrate this a little bit better. But basically what you have to do is you have to take the antiderivative of little f, that gives you big F, plug in b to big F and plug in a to big F, and then subtract whatever the two numbers that you get from those. So another way of saying this, so the integral from a to b of f of x is the same thing as the area under f of x from a to b. These two statements are exactly the same thing. So if they ask you to find the area under f of x from a to b, really they're just asking you take the integral from a to b. So for this first example, so we want to calculate the area under the graph for f of x is equal to x to the third over the interval of 2, 4. So from 2 to 4. So basically, you have your graph of x to the third. From 2 to 4, you want to figure out what all of this area is. To do that, we're going to write it like this. So the integral from 2 to 4 of x to the third dx. So we take the derivative, the antiderivative, of x to the third. That's going to give us x to the fourth over 4. And then another way that we write this, so we did our interval from x to the third. That gives us x to the fourth over 4. And so we're going to draw a straight line, and then we're going to put 2, 4. So that means that we're going to evaluate it at 4 and then subtract it, evaluate it at 2. Or just, so showing you what this means as an equation. So that's going to be 4 to the fourth over 4 minus 2 to the fourth over 4. So 4 to the fourth over 4 is going to give you 64. 2 to the fourth over 4 is just going to give you 4. So then your final answer ends up being 60. So that's all you do. Find the antiderivative, plug in your two numbers, subtract, get your difference, and then you got your answer. All right, so our next one, we're calculating the area under g of x when g of x is equal to x to the negative 3/4 power plus 3x to the 5/3 power over the interval of 1, 3. So that would also be the integral from 1 to 3 of x to the negative 3/4 plus 3x to the 5/3 dx. So first thing we want to do is we want to figure out what our antiderivative is. So figuring out our antiderivative is going to be x to the 1/4 power, 4x to the 1/4 power plus 9x to the 8/3 power over 8. and we are evaluating that from 1 to 3. So this is going to be one where you're going to use your calculator for this one. Usually whenever you have any sort of the rational exponents, you're just going to be using your calculator, getting a decimal approximation, you know, not getting the exact answer, but getting something that's close enough. So we're going to plug 3 into our equation. So plugging 3 into your calculator, we're going to get 26.325 approximately. And then we're going to plug 1 into our calculator and figure out what we're going to get. And that is going to be 5.125. So I recommend plugging 3 in first, solving that separately, plugging 1 in second, solving that separately, and then subtracting the 2. If you try to do it all at once, that's a lot plugging into your calculator, and there's a lot of ways that you can mess up plugging it in. So I do not recommend that. I recommend doing it this way. Figure out your f of 3, figure out your f of 1, and then subtracting them. So then we go through and we subtract our 2, and we're going to get that our answer is approximately 21.2. So we just took the antiderivative, went through and, plugged in our numbers, got our answer. Really straightforward. It's going to be the same way just about every single time. So then next, we're going to do the integral from negative pi over 4 to pi over 4 of secant squared x dx. So we got to look back and remember, all right, what is the antiderivative of secant squared x? What if we take the derivative of it, gives us secant squared? That's going to be tangent. So from negative pi over 4 to pi over 4. So plugging in pi over 4 and then subtracting tangent of negative pi over 4. So tangent of pi over 4 gives us 1. Tangent of negative pi over 4 gives us negative 1. So 1 minus negative 1 gives us 1 plus 1, which is just 2. So make sure you memorize all of your trig derivatives and integrals. You're going to need to have those memorized. That might be a quiz coming up where I would just give you a bunch of all the integrals that are in the back of your book you need to know. All right, so we're looking at the integral from 0 to pi and the integral from 0 to 2 pi, both of sine of x. So before we go through and we compute it using the fundamental theorem of calculus, let's just look at our graph. So our graph, and this is not going to be perfect, but it will be close enough to where you get the point. Your graph looks like this. You've got 2 humps and they're supposed to have equal area. First hump has a positive area because it's above the x-axis. The second hump has a negative area because it's below the x-axis. If we take the integral from 0 to pi, you've just got the area of the one hump. If you take the integral from 0 to 2 pi, you've got the area of the first hump, the area of the second hump. One's positive, one's negative. They're going to cancel each other out. Your total area is going to be 0. And when we work it out with our fundamental theorem of calculus, you'll see that that is going to be the case. So first one, we're going to do first off, we got to figure out what the antiderivative of sine is, and that's going to be negative cosine of x. So then the integral from 0 to pi of sine of x is going to be negative cosine of x from 0 to pi. Plugging that in, we're going to get negative cosine of pi minus negative cosine of 0. So remember back to whenever you were in Algebra 1 or pre-algebra in middle school, and we stressed the importance of watching your negative signs. You're going to have that happen a lot. You're going to have a lot of minus negatives and things like that. So it's real important that you take your time, that you write clearly so you know what cancels out. So this is going to end up being negative cosine of pi plus cosine of 0. So cosine of pi is going to be negative 1. So we have negative 1 plus cosine of 0 is 1. Negative 1 is going to be, positive 1 plus 1 gives us 2. Going over here and evaluate doing the integral from 0 to 2 pi. Well, we already know our antiderivative is going to be negative cosine of x. So we're going to go from 0 to 2 pi. So negative cosine of 2 pi minus negative cosine of 0. So cosine of 2 pi is going to be 1. So negative 1 minus a negative is plus. Cosine of 0 is positive 1. Negative 1 plus 1 gives us 0. That follows exactly what we said up there. So negative signs will get a little tricky here. Just make sure that you are working slowly, you are writing everything down, and you're going back and you are double checking everything. The negative signs in here are going to be a pain. I'm sorry, but y'all will live. So we want to do the integral from negative 0.3 to 0.6 of e to the 3x minus 1. Oh, this one's going to be fun. So first thing we want to do, there should be a dx there. I apologize. So first thing we want to do is we want to take the antiderivative of e to the 3x minus 1. So that is going to be 1/3 e to the 3x minus 1. And we're going to evaluate that from negative 0.3 to 0.6. So then just plugging those in, make sure you are being careful when you are plugging this into your calculator, because there are a lot of ways that you can mess this up. So plugging in 1/3 plugging all the, so we plug in 0.6 first. And we get 0.741847 minus plug in negative 0.3, and we're going to get 0.049856. Subtract the both of those. Going to get 0.691991, or you could just round that to 0.692. And our last two examples, so we're going to evaluate the integral from 2 to 8 of dx over x, and the integral from negative 4 to negative 2 of dx over x. So whenever you see integral dx over x, remember that is the same thing as the integral of 1 over x times dx. Okay? That's just another way of writing it. So the integral of 1 over x, or the integral of dx over x, that is just going to be the natural log. So we got natural log of x from 8 to 2, and the natural log of x from -4 to -2. So we're just going to plug these in. So we got natural log of 8 minus natural log of 2. And if you remember your log rules, you could save yourself some time. Natural log of 8 minus natural log of 2, using your log rules, that's the same thing as natural log of 8 divided by 2. It's just going to be natural log of 4, which if you plug into your calculator, is going to give you 1.38629. So then same thing for this one right here, natural log of x from -2 to -4. So we get natural log of -2 minus natural log -4. So that just gives us natural log of -2 over -4, which just gives us natural log of 1/2, which is going to be about -0.69. Now, you could have also just plugged into your calculator natural log of -2 minus natural log of -4, and it would still give you the same answer. Just whenever you're doing your AP exam, they might give you the decimal approximation, or they might give you the answer is natural log of 1/2. So you would need to know how to use those log rules. And it's not going to happen very, very often. It might be kind of rare, but there is still a chance that it will happen, so you need to know to watch out for it. So we will go over a lot of these in class tomorrow. We will be on integrals for the rest of the year for the AB kids. So get used to this, because we're going to be cranking it over and over and over again until you're sick of them. So let me know if you got any questions, and I will see you all tomorrow.